doing today is we are finishing up 7.41 notes. 7.41. So up to this point so far, we've talked about adding and subtracting fractions, especially with like denominators. If the denominators are already the same, that's very nice because it's just add or subtract the numerators, simplify where needed. Then we went over least common multiple. First expression, we can make both of them be, simplify as far as possible. And now we started looking at being able to factor these here. And I believe we did this one yesterday. Yeah, because I talked about the fact that here we have this greatest common factor of 4 on top and bottom. Now, we could factor it out, giving us 4 over 3x squared, plus, and we factor the x out of both here. We do have this common factor of x, which we technically could simplify out as well and get to 1. But it's kind of as we talked about this yesterday. I think this was the main hour I talked about it in. Here, I removed the x, and that's fine. But to get the denominators to be the same, the right side has x squared. It has 2 of them. So we'd have to multiply by x squared, which is fine. But if I go backwards and say, I'm not going to simplify that x on top and bottom, now it already has one of the x's, so instead of multiplying by x squared, we just multiply by x. So that reduction, that simplifying of x on the right-hand side, really doesn't do a whole lot because we got to put that x right back in. Does that make sense? Where on the other side, that factor of 4, make sure I pull, yeah, 4 we pulled out of the top and bottom. That should be a 2, not an 8. Doesn't go back in because on the right-hand side, there is no factor of 4 that has to be reapplied. There's no factors of 12 that we have to put back in. It would just be multiplying this on top and bottom by x plus 1, and we'd go about solving from here. So that's kind of the point I just want to reiterate and make. Now, if you're not sure if reducing helps or not, you can leave it alone. We can see at the end. Or you can reduce it out, and as it turned out here, all it did was that we multiplied by 3x squared and solved. So the first one we'll actually look at today is this one here. Now, the mathematical way, the pure math way to do this is that we set up our 2 fractions. We're going to factor the denominators as far as possible. Same as what we've been doing. Our 2x minus 2 has the greatest common factor of 2. So if we factor the 2 out of 2x, we get x, and if we factor the 2 out of 2, we get 1, and we get to this point here. On the other side, x squared minus 4x plus 3. There is no greatest common factor amongst these 3 terms. And since the third term is positive, our signs are the same and match the sign of the middle term, which is negative. Now our factors of x squared, we only have one set, x and x. And our factors of 3, well, 1 and 3 are the only ones we have. Even if we did have multiple sets of factors, just like with simplifying our rational expressions or when we were multiplying, how we can use the other factors here, the other factors on bottom, to figure it out, we can still do that to see what the factors are going to be. And the reason I say that is because if we have this here, and we were looking at the least common multiple, the least common denominator, each one of these has an x minus 1 in common. That's fine, especially for this here. I don't have to add that to either side. It already has it in common. That's fine. We don't need to add it to either side because 1 on each side we're good there. Now, the reason I bring that up is especially if, say, this was 2, that means the right side's going to have a factor of x minus 2. Or sorry, the left side's going to have that x minus 2 and x minus 3 on top of anything else. That is an extra factor. That's one more thing we have to multiply, and especially distributing. To where if we do have this x minus 1 in common, that's one less thing we're going to have to get be the same. It helps us out. Less factors to have to work with. So that kind of makes sense. It's one of those things we hope for, so we have less to multiply. Now, as we did it on the first 2, and we did it a good bit yesterday, or some yesterday, the proper procedure is we're going to look at the 2 denominators and find the least common denominator, and list out the terms and find it from there. Personally, especially at this point, now that we kind of get an understanding and have an understanding of what the least common denominator is, I don't feel that doing that and writing that out is a huge necessary step, because the goal to be able to add these, or here, subtract these 2 together, is that we need the denominators to be the same, yes? So the way I look at it is this. Let's start with the right side. So I look at the left, and I want to see, what does it have that the right side doesn't? The 2, yes? So to get them to be the same, I have to multiply the one on the right by 2 on top and bottom. Is there anything else it has, the left side has, that the right side doesn't? No, it has everything else. So really, the only thing we need to multiply the right side by is 2 on top and bottom. We ready to do this again? This time we're going to say, what does the right side have that the left side doesn't? Well, it's missing the x minus 3. And really what we just did was exactly what least common denominator is, but instead of listing it out to this side and going back and forth, we just literally, I'm going to look at this side, see what it doesn't have, multiply it so it has it. So we did the left and right. Questions on this here? So now we can multiply. Now you can distribute the denominators. We can multiply it all the way out. I wouldn't. I would leave it as 2 times x minus 1 times x minus 3. Because with this addition and subtraction, if something's going to simplify, we're going to need it in factored form, so it can cancel out, it can simplify out. 2 times x minus 1 times x minus 3 is factored. And when the denominators are the same, with addition or subtraction of fractions, when we actually go to subtract these 2, we only have that one expression, the 2 times x minus 1 times x minus 3. I'm not having to combine like terms. I'm not going to have to add or subtract. It's just that expression. So multiplying it out, we could, but at the end, we'd have to refactor it back out to make sure nothing simplifies. So there's no reason to mess with the bottom. Now the top, we are going to have to subtract like terms if there are like terms. So for this here, go on and multiply it out. Negative 2x times negative 2 is negative 4x. Negative 1 times negative 2 is negative 2. On the left-hand side, x minus 3 times x plus 2. Our x times x is x squared. X times 2 is plus 2x. Negative 3 times x is negative 3x. And lastly, negative 3 times 2 is negative 6. Well, I think we'll be comfortable. We're about to do 2 steps because I wrote a step ahead, but that's fine. Now, is there a case where I wouldn't just start multiplying everything out? Yes, especially if on top of one of these fractions we have more than two things being multiplied together. You might rewrite it and then take it two at a time. So now that we have two terms being subtracted, we can go on and subtract the numerators. So the left one's still going to be negative, parentheses, negative 4, or minus, parentheses, negative 4x minus 2. The right side, I'm about to do two steps at once. Okay? Because we do have x squared. Wait, what is 2x minus 3x? So we could have done that in two steps. We could have rewrote it, so we had x squared minus x minus 6, and then wrote this, or we can do this. Now, for the most part, the first set of parentheses is going to be the exact same. Now, we got to be careful with the second set because we are subtracting it. That negative has to be distributed through. So that negative 4x is going to become positive 4x. That negative 2 is now positive 2. A very, very common error is to not distribute that negative to the 2 and write it as plus 4x minus 2. It is a very common error, and a lot of places like the ACT will include answers that take that into effect, that make it so that if we forgot to apply that negative 2, that's the answer that they would give us with that taken into account. But we do have to make sure it's applied to both. And once we do that, we can combine like terms. Our x squared is still going to be x squared because there are no like terms. Negative x plus 4x would be plus 3x. And negative 6 plus 2 is negative 4. Questions on how we got to here? Now we can call this done. We can say this is the final answer as long as the top of the fraction does not factor and there's nothing in common on top and bottom. X squared plus 3x minus 4. Does that feel or look like it could factor? Or it looks like it probably won't. That one's kind of hard to say, yes? Unlike some of the ones we did yesterday. If I want to make sure, because our b term is 3, so we can say positive 3 squared minus 4 times 1 times negative 4. Yes? And this tells us it is 5. No decimal, no radical, no domain error. So what that's telling us is that our numerator, x squared plus 3x minus 4, will factor. Now, there is no greatest common factor between x squared, 3x, and 4. If the third term's positive, the signs are the same and match the sign of the middle term. If the third term's negative, our signs are opposite. Since 4 is negative, the signs are opposite. Factors of x squared are x and x. Factors of 4 are 1 and 4 or 2 and 2. Now we need to figure out which one we want to use, yes? What's one we shouldn't probably use? 2 and 2. Because if it is 2 and 2, that's kind of unfortunate. Because if it is 2 and 2, I have nothing in common on top and bottom. Nothing reduces. This is the final answer. And if that's the case, leave it in factored form. Don't rewrite it back here. Because with 4 and 1, I'm going to want the one with the minus. because if we put it with that minus, that negative, we have x minus 1 on top and bottom. That means something simplifies, something's going to cancel. And if we did check it, we would get negative x plus 4x, giving us the positive 3x we wanted. Also means the x minus 1 on top and bottom would simplify, leaving us with x plus 4 over 2 times x minus 3. Questions on this here? Would we agree that the big hurdle is just getting the denominators to be the same? For the most part, this is just a lot of algebraic distribution combining like terms. We were ready for the next one. I do find this one and the last one kind of funny because they're saying find the difference, and they made that entire top, or the numerator of that second rational expression, negative and negative. So there is a negative in common in both, yes? So realistically, couldn't I factor that negative out, which would change that negative, or the minus sign to a plus? So really, we're just adding. Kind of interesting, but well, I went on and factored that one. Now, the other numerator, 5x minus 1. I will say this. If you notice, and there's some cases where the numerator is factorable, even when we get to solving, leave it alone. Because we're going to have to combine like terms with tops of fractions with solving. So if I do factor it, I'm going to have to unfactor it to be able to combine the like terms. Now our denominator, x squared minus 3x plus 2. Third term's positive, so our signs are the same and match the sign of the middle term. Negative and negative. Factors of x squared are x and x. And factors of 2 are 1 and 2. What is the left side missing that the right side has? What does the right side have that the left side doesn't? So we'll multiply through the top. 2 times 5x is 10x. 2 times negative 1 is, well, negative 2. Now, even though they weren't written on the second numerator, we can still think of the parentheses being there, which means we still have to distribute. Negative 2x times x is negative 2x squared. Negative 2x times negative 1 would be positive 2x. Negative 1 times negative x is negative 1 times x is negative x. And negative 1 times negative 1 is plus 1. Now we do need to combine like terms. So our negative 2, or sorry, not negative, 2x minus x, 2 minus 1 is 1, giving us just x. Since the denominators are the same, we can subtract the numerators. And at this point here, really the only thing that's changing, the 10x minus 2 is still 10x minus 2. However, our negative 2x squared is now positive 2x squared. Our positive x is now negative x. And our positive 1 is now negative 1. Last thing we need to do is combine like terms. 2x squared has no terms to combine with. 10x minus x is going to be positive 9x. And negative 2 minus 1 is negative 3. Now, before we can say this is finished, we need to make sure the numerator doesn't factor. Yes. 2x squared plus 9x minus 3, there is no greatest common factor. Now, I am hesitant to try to factor this, especially with two sets of parentheses. Because of the fact that the third term is negative, it means our signs are opposite. So we're going to have addition, subtraction with that middle term. The likelihood that it's going to get to 9 is now low. If they were the same sign, there's a better chance to get there. So I'm going to check our b squared minus 4ac, because that's going to be 9 squared minus 4 times 2 times negative 3. Square root of 105, 10.22, or 10.24. Yep, nope. That's not going to factor. So we're done. If it does factor, we want to go on and factor it and see what it is. If it turns out like the 7.31 assignment, one of the problems that didn't factor at all, didn't simplify, it factored on top and bottom, nothing canceled, we'd still leave it in factor form. Any questions on this here? This one's actually kind of nice. Because our two denominators are already factored, as far as they'll possibly go. Now, part of the reason we look for least common multiple, especially with numbers, is so that we don't find one that's too big. Because normally, our instinct is just to say 7 times 4 is 28. That's the least common multiple. And that works as long as 4 and 7 don't have a common factor. 6 and 4 have a common factor of 2, so just multiplying it doesn't work. 6 times 4 is 24. That extra factor of 2 would have to be removed, getting us back to 12. 4 and 7 have no common factors. So just going 7 and 4 is actually the least common multiple between the two. Because our 4x, the only thing it's missing is that factor of 7. And the 7 is missing the factor of 4, but it's also missing a factor of x. Seven times 4x is 28x. 3 times 7, 7 times 3 is 21. 1 times 4 is 4x. 7 times 4 is 28x. Now, it also seems odd we're actually multiplying these together, unlike the last ones. Well, 28x is factored form. It is simplified form. We have to multiply these. Or if we had a set of parentheses, we can leave the number in front of the parentheses next to each other, because that is factored form also. Since the denominators are the same, we can subtract the numerators. Oh wait, even if really, because it's single term and single term, we don't necessarily need them because there's no sign error with distributing the negative. Nothing comes from that. We get here. There is no x squared term, so our normal factoring is not going to take in. We can't do it. 28, 1, and 4. Is there a common factor between those? No. Because the only factors of 21 is 3, 7, and 21. None of those are factors of 4. So we get this here. We don't have to switch it if we don't want to say negative 4x plus 21. 21 minus 4x is just fine. Questions on this here? I think we need, or one more, and I think we've kind of got a good handle on this. Yes. This seems like it should be different because we have how many fractions? Same exact thing, same exact process. Now, when you rewrite it, leave some space in the middle. Because again, for us to be able to add or subtract these, we need the denominators to be the same. So that means we're going to have to multiply each of these fractions on top and bottom by an expression. So I leave space in the middle to make sure I have room to be able to do that product. Eventually, these are going to all have to be multiplied so the expressions are the same. Now, as I look across this here, x minus 4 for our first denominator, degree is 1, no greatest common factor, that's it. Our middle denominator is x. Does not factor, doesn't simplify, it's just x. Last one we have x squared minus 16. No greatest common factor, but it will factor. Two terms being subtracted. X squared is a perfect square. It's x and x. 16 is 4 and 4. So now we need to see what we need to multiply the others by to get them to be the same. Now we'll start with the far left. This one has x minus 4, yes? What does the other two have that it doesn't have? Well, we start with the far right. This one has x minus 4. This has x plus 4 and x minus 4, yes? So for certain, we need what? It to have x plus 4. Because for those outer two to be the same, they both have to have x minus 4 and x plus 4. What does the middle one have that this far left one doesn't? X. So we have to also multiply it by x. Well, what does the middle one have that the outer two, what does the middle one not have that the outer two do? Well, for sure, x plus 4 and x minus 4. And lastly, what is the far right one missing? Yeah, just x. Probably not. Now the denominators are all going to be x times x plus 4 times x minus 4. Now we're going to have to multiply our numerators together. Now, if we look at the first one, the first numerator, we've got x times x plus 4 times x minus 2. We have three things being multiplied together. Do not multiply all these together. Do not multiply the x plus 4, and x plus 2 all at once, because we can't do that. What I'm going to start with is the x plus 4 and x minus 2. So when we do this here, we would have the x times x, which is x squared. X times negative 2 is negative 2x. 4 times x is plus 4x. And 4 times negative 2 is negative 8. We'll need to combine like terms, and once we finish doing that, we'll distribute that x through once. One thing you cannot do, and I've seen it time and time again, it's very tempting to go here and here, but you're not actually multiplying x through both. You're only doing it to one. Because if you do it through both, you're not actually multiplying it by x, you're multiplying it by x squared, because you did it through two different things. I'm going to skip some steps. X plus 4 times x minus 4. Because we could do this, and there's nothing wrong with saying x times x is x squared. X times negative 4 is negative 4x. 4 times x is plus 4x. 4 times negative 4 is negative 16. Which is x squared minus 16. Now, it seems interesting that I'm just skipping straight to this. But x plus 4 and x minus 4 is what we're multiplying, yes? Where did we get those factors from? X squared minus 16, yes? So if x squared minus 16 factored to x plus 4 times x minus 4, shouldn't x plus 4 times x minus 4 multiply back together to give us x squared minus 16? And it doesn't work just for this here. Two things, if we factored them to get the factors, they should multiply right back. And there are some problems where we see that, oh, let's just rewrite it back to what it was. Last product we have is we have to multiply the 2x squared plus x by x. Two x squared times x is now 2x cubed. 8x times x is now 8x squared. Okay. I need to fix that. That's it. In the middle expression, we are going to have to multiply by 2. In that first set of parentheses, I'm going to combine like terms. We could, if you've already multiplied through by x, that's perfectly fine. We'll get to the same spot. It just tells me that this we just have to multiply through by x, giving us x cubed plus 2x squared minus 8x. Questions on how we got to this here? Good news, we don't have to write x times x plus 4 times x minus 4 3 times this time. Now we only have to write it once. So now we can add and subtract. We have plus between the first two, and we have subtraction between the second and third. Now at this point here, the first expression, we're just going to drop the parentheses because there's no sign in front of it, so the sign's not going to change. Since the sign in front of our middle term is plus, it's still going to stay positive 2x squared and negative 32. The last one, we're going to have to distribute that negative, giving us negative 2x cubed minus 8x squared. Combine like terms. X cubed minus 2x cubed is going to be negative x cubed. So that takes care of our cubics. Now we have 2x squared plus 2x squared minus 8x squared. Well, 2 plus 2 is 4, minus 8 gives us negative 4x squared. Negative 8x. Negative 8x minus 32. Now, this is looking like we can factor by grouping. Negative x cubed, negative x squared, 4x squared. So possibly we can factor out the negative x squared and get x plus 4. We just need to make sure 32 is divisible by 8, giving us 4. So I can factor out the negative x squared. Now it seems odd I'm doing negative and not positive. But if I factor that negative x squared out of negative x cubed, we get positive x. Negative x squared out of negative 4x squared, we get plus 4. Now I'm going to factor negative 8 out of negative 8x minus 32. So it would give me x just showing that this goes to the next step. Actually, a lot of steps, but would y'all agree not necessarily from step to step is a huge, it's a lot of just keeping track of terms, combining like terms, but that's it. Now x squared, the negative x squared minus 8, questions on it factoring because we need to make sure, because it is squared and we do have a subtraction between them, yes, but that first term is negative. So really what we're actually trying to factor, if we got that first term positive, is negative x squared plus 8. We don't have a sum of perfect squares, and also 8's not a perfect square, so it doesn't factor to begin with. But that's it. Questions on this here? Yeah. So really what we're doing is we're saying that x plus 4 is in common in both. So it's a greatest common factor. So I'm factoring it out. We're moving it to the front. So we're treating it like any of the other greatest common factors, except it has two terms. The whole thing's in common, so we move it to the front. Since we have a product on top, products on bottom, those x plus 4s are gone. We get this here. I will say that 3 rational expressions makes this process a lot longer, but I wouldn't necessarily say it is a lot harder than 2. More steps, more paper that it takes up, but not necessarily harder. Questions on any of this here? But that is it.